Skills Practice 47, The Reaction Quotient, by AbrarSyed. Question 1. The following reaction has an equilibrium constant, case of C, of 3.0 times 10 to the negative fourth. At a given moment in time, the concentration of NOBr was 0.81 molar. The concentration of NO was 0.0123 molar, and the concentration of Br2 was 0.0201 molar. Is the reaction at equilibrium? If not, indicate whether more products or reactants will be formed. The balanced reaction was given here. This problem is especially easy. All you have to do is plug in the numbers given into the reaction quotient formula. The answer given, or the answer found, is 0.0755. We have found that QC is equal to 0.0755. The case of C for this reaction is 0.000307. Case of C is greater than case of C. Thus, the reactant NOBr will be formed. Question 2. Consider the reaction 2H2S plus 3O2 is equal to H2O plus 2SO2, where case of C is equal to 2.38. The reaction began, and after a while, the sample was analyzed and the concentrations of SO2 was 0.05. The concentration of H2O was 0.071, the concentration of O2 was 0.162, and the concentration of H2S was 0.059. As the reaction proceeds from this moment forward, do you expect more products to form or more reactants? Explain. In this problem, again, all the molar concentrations are given. Thus, all you have to do is plug them into the reaction quotient formula. Q sub C turns out to be 119.9324. We have found that Q sub C is equal to 119.9324. The K for this reaction is 2.38. Q sub C is greater than K sub C. Thus, the reactants H2S and O2 will be formed. Question 3. Given the reaction 2H2 plus I2 is equal to 2HI2, where the equilibrium constant case of C is equal to 0.0481, the concentrations of H2, I2, and HI were measured at various times. For each of the following sets of data, indicate whether the reaction is at equilibrium or not. If the reaction is not at equilibrium, then indicate whether more reactants will form or whether more products will form to attain equilibrium. Part A. Part A. H2 is 0.27, I2 is 0.4, and HI is 0.31. The answer is simple. Simply plug in all the numbers into the reaction quotient formula, which is products over reactants. QC ends up being 3.296. KC, as we know from before, is equal to 0.0481. Q is greater. Thus, the reaction is not at equilibrium. Instead, the product side is favored. More reactants must be formed in order for this reaction to attain equilibrium. In part B, H2 is 0.46, I2 is 0.34, and HI is 0.28. Again, simply plug in the numbers into the formula, and QC ends up being 1.09. KC, as heard from before, is 0.481. Q is greater, thus the product side is favored. More reactants must be formed for this reaction to attain equilibrium. In part C, H2 is given as 0.8. In part C, H2 is given as 0.18. I2 is given as 0.29, and HI is given as 0.48. Again, simply plug in the numbers into the reaction quotient formula and solve. QC ends up being 24.52, and KC, as still from before, stays the same as 0.0481. Yet again, Q is greater and the product side is favored. Thus, more reactants must be formed to attain equilibrium. Part D. H2 is 0.257, I2 is 0.269, and HI is 0.51. Again, the answer is simple. All you have to do is plug the numbers into the reaction quotient formula, which is product over reactants, and solve for Q. Q sub C ends up being 33.52. K sub C still has not changed and is still 0.0481. Q is still greater, thus the equation is not at equilibrium, and the product side is favored. More reactants must be formed to attain equilibrium. Congratulations! You have now mastered the reaction quotient.